Okay, good afternoon. We are getting down to poem revision. Okay, and then for this poem revision, we are getting down to, can look at question 5, which is on shop floor planning. We'll start with this question because the other time we looked at um, the sequencing rules and the criteria is used to evaluate sequencing rules. So now here we are getting down to, okay, to the Johnson's rule and the Gantt chart. So we'll get down to the Johnson's rule and the Gantt chart. Okay, so Johnson's rule states that if the shortest, processing time, the shortest processing time for the job is in machine A or work center 1, do that job first in the schedule. Okay, but if it is in machine, so if it is in machine B or work center 2, do that job last in the schedule. So this is about what Johnson's rule states. So we can get down to so here, this rule is very, very important. So we're simply saying Johnson's rule states that if the shortest processing time for the job is in machine A or work center 1, do that job first in the schedule. But if it is machine B or work center 2, do that job last in the schedule. Okay? So this is it, what goes on. All right, so we can look at the question paper now. All right. Okay, so now we look at this question. A Lusaka-based printing company has invested in printing press in order to ensure a steady flow of printing jobs. The company has managed to secure printing service contracts with a number of learning institutions in the country. So far, the business appears to be thriving as most learning institutions have no printing facilities for most of their learning and examinations documents required. The operations manager at the company is scheduling the following set of 7 jobs. Okay, as shown in the table below, to process through its press machine and then binding the machine. Processing time at each of these work centers is as shown in the table. What is the optimal sequence for these jobs to be scheduled? How long will it take to complete all the 7 jobs based on your optimal solution? Use a Gantt chart to show the times. All right, so we have the job A, B, C, D, E, F, and G. Then we have printing hours. We have printing hours. We have binding hours. So 15, 7, 4, 7, 10, 4, and 7. 3, 9, 10, 6, 9, 5, and 8. Okay, so this is what we have. All right. So here we have the job. Okay, in printing hours. Here we have also binding hours. Okay, so we have A, B, C, D, E, F, um, G. So we have 15, 7, 4, 7, 10, 4, and 7. 3, 9, 10, 6, 9, 5, and 8. Okay, so this is what we have. So we're going to use the Johnson-Zurach test that if the shortest processing time for the job is in machine A or work center 1, do that job first in the schedule. But if it's in machine B or work center 2, do that job last in the schedule. Okay, so meaning from here, what is going to happen is which one is the shortest processing time here for all the times? The shortest processing time for all the times is 3. Okay, so we do job A at last because it is in binding. You can only bind what you've printed. So A comes here at the end because the rule says that if the shortest processing time for the job is in machine A or work center 1, do that job first in the schedule. But if it's in machine B or work center 2, do that job last in the schedule. So you do job A at last. Then the shortest processing time for these other times is 4. Okay, so since there are 4, there are 2 of them. There is this 4 and there is 4. So here we have to look at which one has the shortest processing time in the other department of binding. So it is the F. So do the job F first. Okay. So do job F first. So F is gone. So do job F first. So F is gone. Then the remaining shortest processing time for these times is actually 4. Okay. So the total processing time, the remaining is 4. So 4, which is C. So C comes here. Okay. So our C comes on this end. So this is our C. Then the remaining shortest processing time, okay, the remaining shortest processing time here is actually 6. So you do job D at last. So D comes here. So do job D here. Okay, for this one. For D. Again, the remaining shortest processing time, in this case here, we have 7, which is B and G. So you do G first. So you do G first. So G comes here. So G first. So G comes here because it has the shortest processing time of 8, shorter time of 8 here. Okay, then 9. Then that's when we can now go for B. Okay. And then the remaining job here is job E. So meaning the sequence comes to F, C, G, B, E, and D. So this is it, the job sequence. Okay. This is the job sequence that we have. Okay, so under this job sequence, the Gantt chart is drawn based on the job sequence. So the Gantt chart is drawn from or using,
What
yes, boy,
subject?
using job sequence. Are we together here? So this question we are doing is from this past paper, all right, where we are simply looking at shop floor planning, and then on the Gantt chart using the Johnson's rule. For those who are just actually joining, okay. So a Lusaka-based printing company has invested in a printing press in order to ensure a steady flow of printing jobs. The company has managed to secure printing service contracts with a number of learning institutions in the country. So far, business appears to be thriving, as most learning institutions have no printing facilities for most of their learning and examination documents required. The operation manager at the company is scheduling the following set of 7 jobs as shown in the table below to be processed through his press machine, then binding machine. Process time at each of these work centers is shown in the table. What is the optimal sequence for these jobs to be scheduled? How long will it take to complete all the 7 jobs based on your optimal solution? Use a Gantt chart. So you look at the smallest of all these processing times is 3. So 3, the Johnson's rule, like I mentioned, is that this rule states that if the shortest processing time for the job is in machine A, work center 1 do the job first in the schedule. But if it's in machine 2, okay, work center 2 do that job last. Do that job last in the schedule. All right, so meaning the job A, B, C, D, E, F, G, printing hours, these are printing hours, and then we have the binding hours. So the top sequence is that since the shortest processing time is 3, so do job A at last, followed by the other processing time. So you cancel this one when you've done it. You cancel the job that has been worked on. The remaining jobs is job 4. These are one which has 4. So check which one has a smaller processing time on the other side. So it's F, which will be done first. Then the other one will remain is 4, which is C. Job C will be done after F. Then the other one is the solid processing time is is 6, which is D should be done this other side. Then we cancel it. Then there will remain a 7. So 7, there is the 7 and 7. There's a tie here when 7 and 7. So check the one which has a smaller processing time on the other side, which is it, which is G. So G comes here, and then the other processing time is 7 here, which is B, and then the other one that will remain will be E, okay, which is this one here, so E. So this is the job sequence, all right? So we have this one as job sequence. So the Gantt chart is drawn by using the job sequence. So we are going to start drawing the Gantt chart, okay? And whatever it is that we are doing here, we are using okay. So, okay, so now the shortest processing time, okay, the shortest processing time here is, okay, we're using the job sequence, which is this one. So we have the printing hours. So this is for printing. And binding. Okay, so printing and binding. So what is going on here is that we are working on the job F. So job F here, as we are doing job F using the sequence C. So job F is actually taking how many hours? Job F is taking 4 hours to finish working on it. So job F is taking 4 hours. Then by the time, so meaning that by the time they're printing this one, these people, they are idle. They are waiting for this one to finish, for them to finish printing F. That's when they can start binding it. Okay. So that's when they can start binding now here. So now this is when they'll start binding F. So for this job to be completed. So binding F is taking 5 hours. Okay, so by the time they're binding F, the guys in printing would have started printing job C. Job C is taking 4 hours. Okay, so C is taking 4. So C is taking 4 hours. And then after they finish C, they can start printing G. They can start printing G. G is taking how many hours? So it's taking 7. G is taking 7 hours, all right, to be printed. Of course, here there is the difference of 1 hour here. So they are starting printing G. G is taking 7 hours. So G taking 7. So meaning that this would have taken 6 hours longer. So by the time they are finishing printing G, what was going on in binding, they were supposed to start binding C for this C to, because F is fully completed. So C should be fully completed. C is taking 10. So C is taking 10. So C taking 10, which is taking 4 hours longer. So by the time they are finishing binding C, by the time they are finishing binding C, let's see what was going on in printing department. Would have been printing job B. Printing job B is taking 7 hours. Okay, so it's taking 7 hours. Printing B is taking 7 hours, meaning that this one would have taken 3 hours longer. Okay, so by the time they're finishing printing B, we see in the binding department what would happen. F is fully completed, they have finished it. C is fully completed, so they'll be printing and I'll be binding G. Binding G is 8. So binding G is 8. So binding G, is taking 8. It's taking 8. And then this one means that this would have taken 5 hours longer. So by the time they're finishing binding G, we see what was going on in printing. In printing, they would have been printing E. So printing E is taking 10. Printing E is taking 10. Okay, so by the time they're finishing printing E, they would have been binding B here in this department. So binding B is taking 9 hours. Okay, so here it's taking 5 hours longer. Okay, and then by the time the binding B is taking how many hours? Binding B is taking 9 hours. So meaning 9 hours, this is 4 hours longer. Okay, by the time they are binding B, meaning that what was going on in printing, they've been printing in D. Printing D is taking 7 hours. D is taking 7, meaning that this would have taken 3 hours longer. Okay, by the time they are printing D, what was going on here is that they would have actually been that's binding E because F is fully complete, C is fully complete, G is fully complete, B is fully complete. E now, our E is taking 9 hours. Okay, our E is taking 9 hours. So E is taking 9 hours. Okay, to bind. That's taking 9 hours to bind. E is taking 9 hours to bind. So meaning this would have taken 6 hours longer. Okay. Then by the time we are finishing binding E, what was going on? Here they would have started printing A. Printing A is taking 15. Printing A is taking 15. Okay, so 15, meaning that this would have taken 9 hours longer. Now, by the time they're finishing, okay, printing A, E is fully complete. D now, they should start binding. Binding D is taking how many? 6 hours. So D is taking 6 hours. Okay, so D is taking 6 hours. So from 9, meaning that there is a 3, okay, that is there. So they have finished actually. F is fully complete, C is fully complete, G is fully complete, B is fully complete, E is fully complete. D is fully complete. Now they should wait because they haven't finished the A. So A is that they haven't finished it. So it's taking this idle time of 3 that these guys in binding should wait for A. Okay. They should go have 3 hours to wait for A. Okay. So waiting for A 3 hours. Okay. So there's the aspect now of they can now start binding A. Binding A is taking how many hours? Binding A, that is binding A is taking 3 hours. So it's taking 3 hours here. So this is the time that these guys will be idle. They will have idle time here. So total time required to finish working on jobs, to finish working on the jobs is actually equal to 4 plus 4. We can add the hours for printing. 4 plus 4 plus 7 plus 7 plus 10 plus 7 plus 15 plus 3. The 3 we're talking about is coming from here. So it will give us the answer there. Then the other one will be a 4 to be, so, or you can go for binding hours. So binding hours, you can say 4 plus 5 plus 10 plus 8 plus 9 plus 9 plus 6. All right. Then plus 3. We can get the value 4 plus 4 plus 7 plus 7 plus 10 plus 7 plus 15 plus 3. So each one is giving us 57 hours. Then this other one will be 4 plus 5 plus 10 plus 8 plus 9 plus 9 plus 6 plus 3. Okay. So we have 4 plus 5 plus 10 plus 8. Okay. Then right, then plus 9 plus 9 plus 6 plus 3. Okay, so the total hours is supposed to be equal to 57 as well. So 57 hours, these are the hours that we need to have. So this is only the Johnson's rule and the Gantt chart. So the 3 is 3 plus 3. So it's a 3 plus another 3 here. Okay, so there are two threes. There's this one and this one. 6, that one, this one, all these ones. So this is about why we are getting down to these answers. Okay. And that one. So the total time is 57 hours that we have. All right. So you just really need to understand this. Okay. You will look at the Johnson's rule, what this rule is all about. The rule that states that the shortest processing time for the job is in machine A or X-Center 1, do that job first in the schedule. But if it's in machine B or X-Center 2, do that job last in the schedule. And these are the job sequences, the printing and binding hours. This is it, what we have. And of course, we have FCGBEDA as a job sequence. Okay. So under this one, of this one, and then the Gantt chart is drawn using the job sequence. So the Gantt chart, I've drawn it this way, and the total time required is 57. So this topic was on shop floor planning. Okay, so shop floor planning and job sequencing. So this is on shop floor planning and job sequencing, where we have looked at this kind of question. All right, so you can get down to another part of the another question here.
I
This
have
one,
a question.
this one. Yes, boss. Yes, you can.
The way we've answered this one
Uh-huh.
is different from the other one, right? Because for the other one, you had said that for the next job to begin, the first job should be completed.
What are
I
you
think
saying?
we looked at three machines, isn't it?
Which one?
The
Which one?
other question had the other question had three machines,
Oh, this one.
if I'm not three processes.
No, this one is it has two machines.
Mm,
This one has two machines. So where are you behind now? Okay, so where are you behind? This one has okay, so this one has what? This one has the two machines. So where are you behind? Hello? Yes, boss. Where are you behind?
Can
So
you get me? Sorry, I was muted. I
uh
said I needed you to clarify something between the two questions. The other one we are looking at the three machines, and then this one has got two machines.
uh
In the three machines, we said we cannot start the process in the next machine until the first one is completely complete.
But
That's why it had some idle times.
but have you followed this one the way I've explained it?
Yes, I have. This one is clear.
Oh,
I
okay.
just need to copy down what you've written on the Johnson's. Uh, yes, there.
Okay. All right. So understand for this one. Then in the other paper, which are the three machines, we'll be able to look at it as well. Okay. So we are revising this.
Okay.
You're
Okay.
revi- You're right. So you've captured it.
What?
Have
One
you?
minute. Let me just finish up. Let me finish up.
Okay, no problem. You can continue, madam. Yeah, I've given you. Oh, okay. All right. And I'm talking to madam. Who is this? This is madam Malolo.
Kapowe.
Okay, no problem, madam. Let's move on. All right. So now we can get down to business. We can now look at question part B. The company has received requests to print standard documents and brochures from its university customers. These being standard jobs, the operation manager has standardized his setup costs for the such jobs. Each job usually requires a different setup, and these changeovers have different costs. The operation manager must decide the job sequence for the 80 jobs. to minimize the changeover cost, the table below. So here, let me give you the rule for changeover cost. Okay. So this one is also in shop floor and it's called changeover cost. So this is simply the cost involved in changing production from one job to another, and we always start with the smallest cost when answering the question. So this is what goes on. Okay. So what is happening here is that as we get down to this problem, okay, so facility jobs that precede, these are a predecessor, these are jobs that start, and these are following jobs. So let us select which one the smallest cost from here, which one the smallest cost from all the costs. Excuse me, you can just look at all these costs. Which one the smallest cost among all these costs? Are you there? Which one the smallest cost among all these costs?
5.
Come again.
5.
And how many fives are we having? There's a 5 here. There's a 5 here. Do we have another 5? Or they're just 2? How many 5s we have? They're just 2, not so. There's a 5 here and a 5 here.
Yes, they're just 2.
So we're going to have 2 job sequences. We're going to have 2 job what? Sequences. Are we together there? Hello?
Yes, yes.
So we're going to have 2 job sequences. So meaning that we can start with either of the 2. So let's start with this 5 here. Okay? There's there's anything special about starting with that 5 here. Okay, let us start with that 5. So what is going to happen is that when you start with this 5, the starting job will be job C, this one here, and you put a 5 there underneath. After C, what happens? After C, we have what?
F.
So followed by F, correct, you're following. So F was now started. So go to F in this column here. What's the smallest cost in F? Smallest cost in F is what?
6.
So 6. You put a 6 here. Where do we go? We go to G.
Sorry, let me take you back. How have we fixed the F?
We have picked the F because this is C. The smallest we started with this 5. Where there is this 5, in this far end, there is F. Are we together?
Yes, it is. Yes, it's clear.
So now, what is going to happen is you go to F. F has now started. The smallest cost in F is what? Smallest cost in F is
6
6. So you go where? You go to G.
to G, yes.
Is that okay?
Yes.
So that's how we're finding this G. So what's the smallest cost in G? In this G, what's the smallest cost in G?
It's 10. 10.
No, you're not. You're not.
The smallest
It's
in
5.
G is 5.
5.
5, yes.
No, put 5.
Sorry, because you have circled 5. So I'm thinking it's
Oh,
already out to it.
no. It was just an indicator of the two smallest numbers. So you go to B.
Okay.
You go to what? You go to B. right? So B, you come to B. What is smallest cost in B?
9.
What's smallest cost in B in what is what?
9.
9. So put the
9.
9 here and go to H. So the smallest cost in H is what? Smallest cost in H. What is smallest cost in
11.
H?
10.
Come again.
10.
It is
10. But since we've already dealt with C,
so C has already been dealt with. We will build up
so the next one is 11.
11, then you go to D. You're following, then I'm happy about this. Then you go to D. The smallest cost in D is what? It's 10. B is already worked
It's
on.
10.
B is already
B is
worked on.
already worked on.
Then the other one,
So 12.
12. F is already worked on.
12, which is F, is already.
Then which other
G,
one?
which is
15 is
15,
already worked on.
is already worked on.
Then 20,
20, there are two
28
20s.
worked on. So there's another 20 here, which is A. But then you go to A. The smallest cost in A is what? Smallest cost in A is
6.
6. C is already
6,
worked on.
but C is already worked on.
Then you go
Then
to
H is
10.
already worked on.
Then you go to
G
G is
is
already
already
worked
worked
on.
on.
Then B is already worked on. Then we go
And
to
then E.
is already worked.
E.
E not worked on. 9.
E is
So
not
we go
worked
to
on.
E. So there's a 20E. And go to E. Are we together there?
Yes.
So E now comes here. In E, what's happening in E? The smallest is what? 10 is worked on.
It's already worked on.
This one is worked on. 20B is worked on. The other one is the 25,
24G is worked on.
25,
24G is worked
24,
on.
and this one, these are worked on.
And 27C is already
So,
worked on.
so everything in. So this one is dash. Then you find the total cost. Total cost will give us what? Add those ones. 5 plus 6 plus 5 plus 9 plus 11 plus 20 plus 20. The answer is it. For this one is 76. Are we together? Okay, have you understood that?
Yes.
So let's move on. Let's go to this other one. So this other one, it is we're starting with G. The first one we started with this 5. Now we're starting with the same thing that we've done. So can I erase this one? Have you copied this answer? Have you copied it? Excuse me, have you copied it? Hello?
Yes, yes, copied.
If copied, I can erase it.
Yes, please.
Okay. So what are we going to do now? We are going to start with this other 5 here, which will be G5 here. So 5, which is will go for B. The smallest cost in B is what? Smallest cost in B is what? Let's go for the smallest cost in B.
9.
9. 9.
9.
Okay, 9. Where do we go? H.
H.
Go to H here. The smallest cost in H is what?
11. 10.
10. 9. So we go for C.
Which is C.
10 here. Then you go to C. The smallest cost in C is what?
Is 5. Which
5.
is F.
You go to F, correct. And then the other one, in F, the smallest cost in F is what?
6, which is G, but
What?
it's taken up.
Where do we go?
So the next one is 10, which is C, which is also taken up.
15B.
Then we have two 15s there. We have two 15s.
So if we
15B is taken up, then 15E.
E, so E, the smallest cost in E,
10.
come again?
10.
10. Okay, so 10 will go where? A. All right. Are we together? So A, the smallest cost in A is what? 6C is taken up. Then 10.
Then H is taken up.
Then
Then 12 is taken up G.
uh-huh.
No, G, yes. Then 15B, which is taken up. Then 20E,
Is taken up. So
which is
25
taken up. 25D.
D. So when you reach the last one, when the IELTS jobs, the last one, don't even do it. Just put a dash because it will show you that all of them have taken up, because you see for D, there will be F 10D taken up, 12F is taken up, then 15G taken up. You find that all of them that are taken up, 20H is taken up, 20A is taken up, 30E is taken up, and the C is taken up. So meaning our total cost for this one will be, okay, 5 plus 9 plus 10 plus 5 plus 15 plus 10 plus 25. The answer is 29. So which one so you can copy this one. So meaning that which one has given us the smaller cost between the two costs? Madam, which one has given us it? The other one they give us a total cost of, the other one was what? Was C, F, G, B, H, D, A, E. And the total cost is 76. So this is the sequence to go for. Okay. So select this one. Select this sequence. Are we together? Are you with me? Hello?
Yes. Yes.
Okay. So meaning that this 2 question 5, all of it has been sorted out. So a topic has been sorted out called shop floor planning and the job sequencing. So this topic, this is what happens, and it doesn't miss. This changeover table, this table is called changeover cost table. This one doesn't miss, please. If you have understood, this is okay with you. So we'll do other questions in the other class. So meaning, take note of the topics we are doing. So in the other class, I'll select another topic, which will be maybe inventory management. Okay, so this question was shop floor planning. The other one here was MPS, and this was repeated. This was master production schedule, which is question 6. All right, then
When are we going to go through the MPS?
so okay, so let's see. This one was the MRP. Okay, and then we can this one is on forecasting.
Linear regression.
Yeah, which is for regression. This is inventory. Okay, so this is inventory management. And then this other one is aggregate planning. Aggregate planning. So please take note of this. So Mr. Job will schedule a class for you so that we can come and do this in another class, which is the MPS one. I think in another class we need to do the MPS one. All right. So don't worry about it. All these questions will be catered for so that you can get ready for your exam. So we can end here for now. So the other class will be advised when we are going to have it. Okay.
Okay. Thank you.
Yeah, most welcome.
Please share the video.
Okay, no, okay, you're welcome. I will do so.
Thank you.